So now we continue and look at the graphing of the quadratic equation, still on coordinate geometry. Now, these are shapes of quadratic equations. So you will get them in these two formats. Now, you will see that this graph grows this way, and that graph grows that way. That's the primary thing that we need to know. Okay? It doesn't go anywhere beyond here. It doesn't go anywhere beyond there. Meaning that this graph, okay? Meaning that this graph can only grow this side. That graph can only grow that side. This is the first visual that we need to have, right? Then the second thing that we need to know about quadratic equations is that we are going to maintain the same form of the equation, which is ax squared plus bx plus c equal to 0, like that, right? What is crucial now to know, the next thing is we need to know a number of things. The first is the solutions, okay? The solution set. So this is where it intercepts the x-axis here and there. What is the value here? This is when y is equal to 0. Number one concept. Number two concept, we need to understand this point here, the vertex. So they call this one the vertex. We need to know this, okay? The number 4 point is that we need to understand this point here when x is equal to 0. When you have these 4 aspects, let me write them down here because these are so crucial. I'll write them in green. Number 1, you need to know the general direction. Okay, direction of the graph. Number 2, the solution set. Number 3, the vertex. Number 4, it's the y-intercept. If you know these, then you can graph the quadratic a quadratic equation onto the graph. So now, what is important here? What is important is to know the general direction, the solution set, the vertex, the y-intercept. That's what you need to carry with you as we go through these series of equations. Okay, now let's say you've been asked to plot a graph of an equation like this. So we said that you need to know the general direction. Okay, so the general direction, assuming this is positive, so I'll just do this, okay? Then I'll get my solutions. So if I get my x is here, maybe x1, x2 will be there. I calculate the values of the intercept, the vertex. Then I calculate the value of the intercept, like that. Then all I do now is that since I know the general direction, I can come and do this. Now, we usually miss just a bit. These don't have to be accurate when we are doing them at this level. We just need to have a general direction of that. So you had the value of here, you had the value of there, the value of here, and this value. This value, that's why it's not very common to include it when you're drawing, but you just need to know this one, that one, and that one, and then this one finds itself as you're drawing it. Okay, so you don't need to have accurate values like everywhere it's going through where you want it, but it should be in that general direction. So if you understand that this is positive, when it's positive, then you know your graph will open this way. The main reason why it opens that way is that the values of x squared keep on increasing. So whether it's negative, it's positive, they'll keep on increasing. The values of x, they'll keep on going that way. The reason why it goes downward like this, when you have a negative value here, it's because this will always be negative, meaning that as you are going towards infinity, this side and that side, this value will overpower these two values. Regardless of whether they're subtracting or adding, this will overpower the rest of the values. And so the general direction will follow this value here. Okay, so for example, if x is at infinity, for example, we'll have the square of infinity is here, but here you have a single infinity, there you have none. So the biggest value will come from here. So if this is negative, the general direction of the graph will be negative. If this is positive, the general direction of the graph will be positive. Let's do the actual points. So this is y is equal to ax squared plus bx plus c. Right. So what we need to understand is that the solutions, okay, the solutions for this equation, y, okay, is going to be this value. But x, the values for x, we'll get them through the, you can do the factorization method, or you can do the completing the square, or you can do this one. Doesn't matter, as long as you're doing it correctly. So this is, you get your x values. So this is 1. The general direction, we'll get it by checking the sign of this one. Okay, so the sign of that one, we'll have an idea whether this is opening upward or it's opening downward. Now, we've got the values of x, and remember there are 2 based on this, because 1, you take the positive route here, 2nd, you take the negative route. Then the other value we said was important was the vertex. The vertex comes from the completing the square method. And so the value they say is like this. Y, when you complete this, it becomes a like that, x minus h squared plus k. Okay, when you change the format of this equation to that format here, okay, through completing the square, the value that you get here and the value that you get there of h and k gives you the vertex. So the vertex is h comma k. Okay, so it's easy. We've already used this formula and how to get it, and we know how to solve, or to solve quadratic equations. The solutions that we get, they give us the points on the x-axis, okay, because there y is 0. And now let's try to learn how to come up with the vertex, because we already know how to do the solutions. So this next section, we'll try and know how to come up with the vertex. Let's get the vertex. So our formula is ax plus bx plus c. So we're going to go with completing the square method. We say that first, x has to have, for us to use it, x has to have a coefficient of 1. So that's why we factorized a, but then that will impact this one as well. A, okay, x, then plus c over a, like that. Then we look at this and we complete the square there. Y is equal to a. If we completed the square of this, we're going to end up with x plus b over 2a, that we're going to square. Then the same time, we're going to take away the square of this, okay, which is b squared over 4a squared. Then plus c over a, right? Now, we need to remember that we are trying to have it in this format. Okay, so already we now need to expand this. Okay, we need to, first of all, before we expand, we need to set it up that it can be in the same format. So that becomes over 2a squared. Then here we say plus. If I say plus here, then this minus, we need to go inside the brackets there. Okay, so it will be minus b squared over 4a squared plus c over a. Right, I can factorize this. Okay, so it's going to be a squared, a, like that, then x plus b over 2a squared again, and plus. Here, I go into my brackets and I'll have, so let me simplify this. Here I'm going to have, let me set up the negative that is for all the values. So it's minus here. Then this one on top here has become positive because now I'm saying the whole statement is negative. Okay, not just b squared. So that changes this one into negative 4ac. Notice I'm saying the whole sign there. So this has become positive. And then at the bottom, we're going to have 4a squared. Check out the video on the negatives and positives. That will help you to understand what has happened here. It's the same. Remember, if we say minus b squared minus 4ac over 4a squared, this is not the same as minus b squared minus 4ac over 4a squared. These are different. This is the same as this, like that. And this is the same as that. Notice where the negative now is. Different places. I can't expand this negative to anywhere else. I'll have to keep it there. But here, I can expand this to minus b squared. Then it will change this into a positive. So when it's in line with this over sign, then you know that it's applying to the whole statement. When it's just next to this letter here, okay, it's applying just to this letter, not to the whole equation. That's why I put it there. And then I changed the nature of my equation there. Okay, to mean that b squared now is positive, but 4ac is negative. Or if you want, you can put this in brackets further like that. Okay, so now we continue. We expand with the a. The a stays with x plus b over 2a, like that. We square, and then here we maintain our plus. Now remember, I'm going to simplify it. I'm going to keep it like this so that it's easier for us to pick it out. Minus. And then what we'll do is we'll maintain this b squared minus 4ac, like that. But this a can come in and cancel part of this. So this becomes 4a, like that. So now we see that these are in the same format, which is y. This is y. Then I can put y is equal to a, which is the a there. Then x minus h squared. This is the same. Plus k. So we have the plus, and then we have the k. Meaning what? Meaning that we can now say that x or h is equal to minus. Remember, this is minus and that is positive. So at the end of the day, if I want to say h, I'll have to transfer the negative to this guy here. So it will be b over 2a Okay, that's the vertex. So this is x at the vertex. Okay, x at the vertex. What is k? What is the coordinate of k? What is y at the vertex? It's going to be this. So what is this? What is this? This is k. So we're saying that k was positive, this is negative, so we maintain what it was. So this is minus b squared minus 4ac over 4a, like that. So these are your coordinates at the vertex. So the vertex, we conclude it like this. hk at the vertex is going to be minus b over 2a, comma, minus b squared minus 4ac over 4a, like this. So this is another of the formulas that we need to master. Okay. They've given us this equation and they're asking us to sketch the graph of this quadratic equation. Now we said that there are 4 steps. The first is to find the general direction of this graph. So this is a positive number, so we expect it to open this way. We explained why this is so. It's because of this. This is more powerful than these two because it's got 2 x values here. So for example, as we are approaching infinity, these will be very huge numbers, 2 very huge numbers multiplying each other. But this one will be a 6 and that huge number. Then this one will remain as a 5, meaning that even if we were to add these two, it's impossible to compare with the value that we get from here. And that's why it's opening upward. Whether it's negative or positive value of x, there will be, remember, even if it was negative infinity, we square it, that becomes positive infinity. So still it will go up, whether the value of x is negative or positive. So we know that the graph is opening upward. 2, we look for solutions of this graph when y is 0. Okay, we say that the product is 1, then to get minuses here, it means that we've used factors of 1 and 5, okay, equal to 0, meaning that those 2 solutions, we're going to have x is equal to 1 and 5, okay? So those are 2 solutions. We've ticked the first point, the second point. Then we have the third aspect, it's to find the vertex. We said that at the vertex, x is equal to minus b over 2a, okay? So what is minus b? Minus b is going to be minus 6 over 2a. A is 1. You can see that a is 1 here. So meaning that we're going to have 2 times 1, which is 2. The top part gives us positive 6. The bottom part gives us 2. Those 2 divided, we have 3. What is the y value? Y value, you can put it in this equation here, the value, the 3, and find it. Or if you are able to remember, we said it was b squared minus 4ac over 4a. So we can go minus. The minus is not in front of b, it's in, for the whole expression. So then we do b squared, which is 36, minus 4, a is 1, and then c is 5. Then we divide by 4 times a, which is 1. So now we have what? Minus. Here we have 36. Here we have 20, so that's 16. We say 16 over 4, and so we get minus 4. Okay, so this is the second part. We have the vertex. So our vertex is going to be 3, 4, 3, negative 4. And then what's the next thing that we can work out? We're going to work out where x is 0. So y is going to be x squared is 0, minus 0, 6 times x, then plus 5. So y is equal to 5. So at the point where x is 0, the graph crosses the y-axis at coordinate 0, 5. So we have our general direction, we have our vertex, we have our solutions, and then we have this. So now we can graph our thing. So it's going to be, okay. I don't want to use lines, I want to draw so that we can actually have a feel of what's going on. We can get lines, put them down, and we don't want to do that. So now we use the solutions. So these solutions are 1. Okay, those are the first ones you must put. And then we put a 5 there. So this is going to be 1, and that's going to be a 5. What other point can we look for? It's this 3. So we're going to say this is -4, because this is the y-axis and this is the x-axis. And then here we're going to say 1, 2, 3, 4, 5. So it's going to be somewhere in the middle here. So this point is going to give us the vertex. So we show it there. Which other point can we include? We can include a point here. Okay. Here, where y is 5. So meaning that now our graph will be something like this. We connect here, we bring it down, it connects here, we bring it down, connects here, we bring it up, connects there, and here it just continues like symmetry, like that. Okay, so this is how you draw the graphs of quadratic equations. All right, thank you. Okay, so this concludes our section on fundamentals of pre-calculus. Thank you for following, and all the best.